Welcome to tutorial 3, question 3. Let's do this. Alright, so I'm going to put the question right over here. Read it over, attempt it yourself, and then, as always, we're going to go through it together. Alright, so by, taking a look at number 3, the code that we have, I is going from 1 to n. Remember, guys, when it comes to Python, when they say range, when it says 1 to n plus 1, the n plus 1 is not inclusive. So it goes from 1 to n. Always remember that for Python. Same thing goes with J, same thing goes with K. Now, when you go I goes from a range of 1 to n, and J goes for a range of I to, n, and then, for K in the range of I to J, and then we keep adding 1. A nice way of putting it is, if I point, it should come, so. Yeah, it's lame when you do that, when there's animation comes later. What am I doing, God? SMH. But anyways, the summation, obviously I'm going to put it here, but you can write it like that, because think about it. It goes from I equals 1 to n. That's the first for loop, right? Again, remember, n plus 1 is not inclusive Python stuff. And the second summation is j equals I equals till n. Again, same summation, makes sense. But then what's going on here, bro? J minus I plus 1. And then there's a third. Where's the third for loop? Well, think about it this way. When it says for k in the range of I to j plus 1, if you look inside of that for loop, it keeps adding 1. Meaning every iteration of k, this guy is adding 1 to the total. To me, we can optimize this code, mathematically speaking. I'm not trying to do that, for them, but it makes our life easier for our own calculation. So let's do that. Can I change for k in range of I to j, or again, I almost got myself. Can we change that to something nicer mathematically? Well, what does that third for loop calculate? From the looks of it, it goes from I to j. It gets the difference from I to j and plus 1. And what I mean by plus 1 is that, alright, it goes I, including that, right? That's plus 1. Then it goes to I plus 1, I plus 2, blah, 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 and then j included. So if we say j was 5 and I was 3, right? It goes 3, 4, 5. It did it 3 times. But here's the thing. 5 minus 3 is equal to 2. So it can't simply be j minus I. You got to do a plus 1 so it matches the 3 when it calculates it. So that's why we do j minus I plus 1 to replace the third for loop. Now, let's switch it up and you'll see why I keep doing this. If you don't kind of understand it, it's fine. It's fine. We'll just keep this formula that we have, summation of I going from 1 to n, and the summation of j equaling I to n, and then, j minus I plus 1. Let's tweak it a little bit. Let's let k equal everything in that summation, the whole j minus I plus 1. Let's let that equal to k, okay? All right, we're going to do that. Then if we arrange that, the whole k equals j minus I plus 1, if we arrange that in the terms of j, and I want to put that right here, it's going to equal j equals k plus I minus 1. So if I want to, if I really want to, I can, the summation over there, it goes I equals 1 to n. That's the first summation. The second summation where it says j equals to I to n, we know what j is, so let's replace j with k plus I minus 1 equals to I to n, that summation, and replace the entire bracket that we had before, j minus I plus 1, with a simple k, right? Okay, bear with me though. I know it's getting confusing, it's getting out of hand. We're just going to put that there. Now, we can rewrite this new formula we got by just making sure that the whole k plus I minus 1 equal I thing is cleaned up, right? Whatever we do to the bottom one, we got to do to the top one. So it says k plus I minus 1 equals to I. We bring the plus I and minus 1 to the other side, right? And it becomes k equals to 1. The i's cancel out, and then the 1 gets a positive because it goes to the other side of the equal sign. And k equals to 1. But we gotta do the same thing to n, right? So n becomes n minus I plus 1. When n becomes, and we have a new formula. It becomes summation of I equals to 1 to n, and the second summation is k equals to 1 to n minus I plus 1, and then the terms are just k, just a simple k. So this new formula we got, we're gonna put this at the top, and that's the sum. So how can we upper bound it? I want to move into the whole big O scenario, and when we do big O, we gotta make an increase, right? If I want to do that, how can I make this larger than before? Well, if you look at the second summation, we have n minus I plus 1. Well, I is dynamic, it's variable based, right? And plus 1, right? How about I get rid of the whole minus I plus 1? So it just becomes n, just to make matters simpler, and it's big O anyways, we're making things larger. So the new formula becomes summation of I equals to 1 to n, and then summation of k equals to 1 to n. And then, let's change the k that's in front of this entire thing with, I don't know, n, because n is bigger than k. That's the one thing we are positive, that k is bigger than n, because k gets maxed out at n if you think about our summation. So let's change that to n. Alright, fine. That's obviously upper bounding our original formula. Okay, but looking at this, summation of I equaling 1 to n, and the summation of k equaling 1 to n, and then the factor in the front is an n. This is like n happening 3 times to itself, like a n cubed kind of thing. And that's what it is. That's the big O of this function. Its big O is n cubed, n to the power of 3. Now for the big omega side of things, let's revert back to the OG formula we had, but not the OG one, like not the very original one. I'm talking about the one that we just made, the whole square root of not square root, summation of I equaling to 1 going to n, and then the second summation of k equaling to 1 going to n minus I plus 1, and then there's a k in front of it. I want to put it up there. Let's, for the simplicity, for the lower bound, we're going to assume that for the simplicity that n is even. Just for simplicity's sake, we're going to say that n is even. Then, if you think about it, in order to make this simpler or smaller, we can just take the first n over 2 terms. What do I mean by that? You know how the first summation goes I equals to 1 to n, right? I'm going to square that out in the formulas right there. Let's make it an n over 2, the top one. Why not? Because that way we're actually making it smaller. The summation that keeps happening, we just cut it off by half, right? Let's divide it by 2. And then, once we've done that, I can get capped at n over 2. It's never going to get bigger than n over 2, right? So if you look at the second summation, n minus I plus 1, okay, we're going to put n over 2 in the place of I. In the worst case scenario, right? Let's say I is equal to n over 2, right? We're going to put that in as I, right? Sorry, that power's going to shut down. But so it's going to be n minus n over 2 plus 1. So it's basically it's basically going to say n over 2 plus 1. K, the second summation is k equals to 1 goes to n over 2 plus 1. And then there's a k obviously in front. All right, let's make this simpler. Let's say not plus 1. Let's just say n over 2. We just got rid of 1. You know what I mean? Instead of saying the second summation to go, n over 2 plus 1, let's just say, n over 2. And think about it this way. I being anything else below in the first summation, it can be smaller than n over 2, right? It's still, the second summation is still going to have more than n over 2 terms. So for each value of I, the k sum has at least n over 2 terms. And we're making it smaller. So we're going to make it as small as we can. And we're going to make it n over 2. And now that we get to this point of, just a k there, and then both of the summations are capping at n over 2, and they both start at 1, let's look at the inner one. Let's look at the second summation. We can change that. There's a close form for that. It's an easy one. I think a lot of us should know that by now. We're going to change the inner one to n over 2 times n over 2 plus 1 divided by 2. We're going to keep the second summation there, but the outer summation there, the whole I equals to 1 n over 2, but then we're going to keep this one here. Now, the one remaining summation that's there, well, it's grabbing this thing and it's adding it to itself, because obviously I is nowhere to be present in this new formula. So it's basically adding this formula to itself n over 2 times. So why not just multiply this formula by n over 2, right? To me, that makes sense. It gets rid of the mumbo jumbo summation mathematics that, whatever. And then, it gets the job done. So it becomes n over 2, because we're multiplying it with the rest. And whatever it was in front of the summation, which is n over 2 times n over 2 plus 1 divided by 2. Mathematically, you get rid of the garbage that's here and there and simplify it. You hit the point that big omega is n cubed. There's 3 n's. You get rid of the divisors by 2 and the plus 1 because you're trying to make it smaller. You hit the big omega of n cubed. And remember, sorry, camera cut out, so I have to re-record this part. But, when you simplify that, you get n cubed for your big omega. And since we already got our big O, and we already got our big omega, both of them pointing to n cubed, we've proven that the theta is n cubed. It holds for the question. And that's pretty much it for this question. Now, there's a good reason for why we did what we did with the whole K stuff and the J stuff. It's very confusing. I'm not even going to explain in this video. If you go to my, where you find this video, right there should be Google Slides that I want to have. And in there, you can see what the prof gave, and you can read it through yourself. It's written in latex-ish. I don't know how fun that is for you, but read it over. I don't think there's a good use of time because it's long. But, if you feel like, you want to see why we did what we did and what issues we, passed by doing what we did, by all means, you can go check it out. All right, that is all for exercise 3. I'll see you guys in the next one.